All right, and now for your lab. Thank you. All right, binary trees part 1. Hey, it's going to be, this looks actually very similar to what we coded, except for it's a binary tree node, which is okay. I think we can change that. I called it a binary tree here. It's still a binary search tree. I just called it a binary tree. It looks like I put the put from a previous class. This time I called it rover, a new node. You can call it add in what we did as well. It's perfectly fine. And there's going to be an in-order string because it's going to be a little tricky how we're going to go about how I'll test your in-order function call. But we'll get to that momentarily. All right, naturally, you want to be able to create a binary tree empty. The second thing is to create a binary tree from another binary tree. Excuse me, so you got to do a deep copy. Anyone think about how we could go about doing that? Right, so we do a pre-order traversal of the new tree, and every time we visit a node, we call .add on our own tree, so it'll just add it there. That'll work. That's fine. And then, of course, you need put. Here I called it put. In my class, we called it add. Hopefully, y'all are able to make the change. You got this, Perry? Okay, good. Get height to return the height of the binary tree, as we discussed up there. You're just giving me a funny look, like this is going to be way too hard. I'm like, all right. All right. In order string returns a string representation of the binary tree in order, aka what we just printed out here needs to be in a string. So you need to think about how you can pass a string to our print function to update it as it's as you're going through it. Y'all see the difference here? All right, so make sure you're returning a STL string. By the way, make sure you call .trim when you're done. So any extra white space you have is not in there. Otherwise, you're going to fail that test case miserably.
So you don't use find, you use double equals?
Let's see, what do I use? Yeah, probably. Yeah, I do double equals. All right, so here's the first kind of tricky part of binary trees. I tried to make this print out nicely, but it wouldn't. The next one is going to call it LCA. You return the lowest common ancestor of two values. Lowest common ancestor. So this makes more sense when you have examples. So in this binary tree that didn't get spaced out quite right, the root is 4. He has 2 and 8 as children. The 2 has a 1 and 3, and the 8 has a 6 and a 10. Okay? Maybe, okay. So 1 and 3, the lowest common ancestor is the 2. 1 and 2 is just the 2 itself, because 2 can be in, well, we're going to say 2 is an ancestor of itself for the sake of argument. Now 1 and 6, in order to get to a common ancestor, you have to go all the way up to 4. And then that's the lowest common ancestor of those two numbers. So the lowest, y'all see what I'm saying here? What's the lowest common ancestor of 1 and 8? 4. Okay, good. So I'm going to give you, well, after I make your binary tree, I'm going to call, ask, yes?
Why would it not be 8?
1 and 8, right, because you have to go up to the 4. Yeah, the arrows are a little confusing here. Sorry, it just wouldn't print out correctly for some reason. And don't forget to free your memory.
Didn't you have memory?
What's that?
Don't you have a memory link in the one we ordered?
How would you free your memory?
Reverse it.
Right, so which type of traversal?
I would say post order.
Right, you want to do, yeah, so you want to do it again traversal, but post order, so that when you're finally done with the node, let me go back here. Let me erase these 3 extra nodes we created so this makes sense. You want to do a post order because once you're finished with a node and you're not going to use any of its children, then you can delete it and return. Luckily, it's recursive, so you really just have to put the word delete in there, and then and then the stack is going to keep track of where you are and deleting all your nodes. Okay? If you do it recursively, it's going to be easier than in order. The incremental. Yeah, incremental or method of coding, which is not bad. Some of these are actually a little better if you do it procedurally as opposed to recursively. All right, hey, and that's it. And this should be a week from today. Is that a week? I don't think so. I'm going to add one more day to that. I'll add one more day to that, so it'll be on the 27th. And I'll make sure I upload all the code. What's that? Next. Go ahead.
Also, from the last class, what movie project could use since we're going to be over spring break?
Oh, yeah, thank you. Okay, let me write that up. I need to update Lab 14.
Can it be due the first class that we're back?
Yeah, that's what it's going to be. Yeah, it'll be the first day of class that we're back from spring. I got to update the day here. These are my notes. No, we don't have class 2 weeks. Right, not next week, but the week after, because that's spring break. Oh yeah, wait, did you want your midterm before or after spring break?
Oh, we decided before.
Before? Okay, so it'll be a week from this Thursday. So I'll have to set that up and explain what's going on. Yeah, it'll be the day before. That way you'll at least know if you need to withdraw. Any other questions? All right, great. I will let y'all get started on your lab. Before I start answering questions, give me a little time to fix all these little errors, unless it's really fast.
Quick question. If we do